This is CIS18A, Unit 2, Part 2, which covers operator. So in this video, I'm going to talk about operator and different types of operator in Java. So to start, operator is just a symbol that tells the compiler to perform specific mathematical or logical manipulation. So there are 4 general classes of operators, and we need to know this for quiz and tests. So there's arithmetic, bitwise, relational, and logical. And to start, we would touch on arithmetic operator. We saw some of this in week 1 assignments, where we would use arithmetic operator for calculations of various things. So to start, we would use a plus sign for addition, or also known as unary plus. So if you need to add values together, you would use a plus sign. Subtraction with minus sign would be used for subtraction, and it's also known as unary minus. We would use an asterisk for multiplication. We would use a slash for division. We would use the percentage symbol for modulus, or we would call this modulo or modulus. We would use the double plus sign for increment. That means it's going to increment, add 1. And then we would use a double negative sign for decrement, subtract 1. So in the below program is an example of using a modulus operator. And what modulus does is it would, when we use this, it would give you the remainder as an output. So in this program, we have a class mod demo. In the main method, we have multiple variables. So first variable is iResult, and it is an integer. The next variable is irem. It's an integer. And the third variable is dResult, that stores, it is a double, and drem is a double. So for iResult, we would take 10 divided by 3. So with that, if we output that, that would be a decimal value. Irem, we would have it 10 mod 3. So it would take 10 divided by 3, which is 3 as a quotient and 1 remainder, because we have 1 left over. 3 times 3 is 9, and we would have 10 divided by 3, we would have 1 remainder. So if we output that, that would be 1. The result, we would have 10.0 divided by 3.0, and note that we're using double here, so we're storing decimal here. So with that, we would see the decimal value as it is a double type. Compared to iResult up here, even though it is a decimal value, it's going to truncate that, and it's only going to give you 3. And then drem, we would have 10.0 mod 3.0, which is going to give you 1 still. So here we have it output, result, and the remainder, and for the int and the double. So with this program, I would run it and show you. So in this program, as we previously talked about, we do see that for the int result and int rem, so when we did the iResult here, we have whole number 3 and 1. As we would have the iResult and irem, so iResult 10 divided by 3 gives us a 3 whole number, and then for the remainder, that would be 1. For the next output, when we use double, we have a long decimal number as output, as 10 divided by 3 is 3.33335, And then for the second part, the remainder is 1.0. As you can see that when we use the double, it puts in the decimal point, and when we use the int, it truncated that. And that was one of the questions for week 1 assignment. As you completed that, you probably attempted to change the type and test it. So if you're not sure, you can take a look at how this program is written and run it, and so you can see it for yourself. So in the next part, I'm going to talk about increment and decrement. So in chapter 1, it touches on increment and decrement. Increment and decrement operators, simply increment adds 1 to its operand, and decrement operator subtracts 1. So when we have x is x plus 1, that will be the same as x plus plus. And also x is x minus 1, it's the same as x using the double minus sign. So there are 2 formats in this. The first one, when you're using the double plus sign in front of the x, we call this the prefix form. And when you're using the 2 plus sign after the x, this is called postfix form. So when it's after the variable or the number, it's going to be postfix. When it's before, that will be prefix. Now here, it shows some example. We would have x is 10 and y is the prefix of x. So we would increment of x. So in this case, y is set to 11 because we would have 1 plus 10. Now, in the next case, we have x is 10 and y is x increment in the postfix form. So y is then set to 10, as in the previous case, y is set to 11. Now, x is still set to 11, but we have to take a look at how it is used for the increment, whether it's prefix or the postfix, as y is equal to either the prefix increment of x or the postfix increment of x. So that's important to note, and you would likely see a question like that on the final quiz. For the next part, I'm going to talk about relational and logical operators, and this is important when we touch on chapter 3, because then we would apply this to conditions or control statements. So relational operators really refer to the relationship with the values, how one value can have a relationship with another. And logical operator really refers to which is true and false as values and how they can be connected together. So in the relational operators on page 13, here you would see a table. When you have a double equal sign, that really means equal to. When you have an exclamation point and equal sign, that means it's not equal to. And then you have a greater than symbol, a lesser than, greater than, and greater than or equal to. So you can have a combination of these two, or you can have less than or equal to. That these are the relational operators, and we can have the value on the left compared to the value on the right using the relational operator. For the logical operator, you would see a table right below the relational operator on page 13. The operator, we can use the ampersand that means and, we use the pipe for or, and then we would have exclusive or, short circuit or using double pipe, short circuit and using double ampersand, and exclamation point for not. And for how it would apply with the logical operator, when you have, so on the page 13, it gives you the table on how and is used. So when we have false and false, what that would be result would be false. True and false would be false. False and true would be false, and true would be true. So in the case of and, anytime that you have a false, it will be a false outcome. With the or, when you have false or false, you would get a false. True or false, you get a true. False or true, you would get a true. True or true, you would get a true. So in the case of or, anytime that you have a true, you would have an output of true. And on the next column, it gives you the output for exclusive or, and for not, using the exclamation point here, it is the opposite. So, and it is the only operator that's unary in the logical operator set. So if I have a false to start, I would have an output of true. If it's not false, that will be true. If I have a true to start, and if it's not true, I would get a false as an output. So on page 13, you would see this table. Please refer to the text or page 13. So on page 14 provides an example of how relational operators is used. And in this example, we have a main method. We have two variables that are integers, I and j, and then we have two variables that are Boolean. I is initialized at 10 and j is initialized at 11. And after that, we have if statement. If I is less than j, it would print I is less than j. So in the if statement, it would check for this condition is true. As I is 10 and j is 11, that condition is met. It is true, so it would print I is less than j. For the next if statement, if I is less than or equal to j, the system would print I is less than or equal to j. Since I is 10 and j is 11, it would then print this. So here I have the program that's shown in the example written and compiled and ran. So as you can see, as we talked about the first two statements, that would output that because the conditions are met, they are true. On the next one, it says if I is not equal to j, it would print I is not equal to j. And I is initialized at 10 and j is initialized at 11. That condition is also true. So it would print I is not equal to j, as you see in the output. So that is true. On the next line, if I is equal to j, this won't be executed. So I is 10 and j is 11. This condition is not true, so it skips this and it did not execute that line. It did not print. This won't execute, and you would see that on the output here. And on the next line, I is greater and equal to j, this won't execute. So I is 10 and j is 11. I is not equal to, or not greater than or equal to J. So it then again would skip this because it's not true. And lastly, for this if condition, I is greater than J. 10 is not greater than 11. So again, it would skip the output for that string. Now for the second part of the program, B1 is initialized as true and B2 is false. And for our statement, we have if B1 and B2, then the system would print, this won't execute. So we would have true and false that would give you false as a result. So therefore it did not print this line. This won't execute. For the next statement, if not B and if not B1 and B2, that means if not true and false. So since we have false on the inside and when we not it, it would be true. It would then print this text. Not B1 and B2 is true. So you would see that as an output here. And then on the next line, if B1 or B2, so B1 is true and B2 is false. So when you have true or false, you would have a true. So it would print B1 or B2 is true. And that's what you have at the output on the left here. And lastly, on the last if statement, if B1 exclusive or B2, we would have the output true. So it would print B1 XOR B2 is true. Therefore, you have the last output of the statement there. So as you can see how we would use the logical statement. In this case, we use with the if statement. And you can have it with Boolean type or int in this program. And you can see how that would check for the if and if only would execute the body of it if the condition is met or if the condition is true. So as we've seen previously in the notes, we saw that the double ampersand is a short circuit AND operator, and the double pipe is a short circuit OR operator. So here in the notes, it states that their normal counterparts are AND and OR, single ampersand and a single pipe. So the only difference between the normal and the short circuit is that the normal operand is always evaluate each operand, but the short circuit versions will evaluate the second operand only when necessary. So that's the true difference between the two. So make note of that. Below on page 15 is an example of how you would use the short circuit operator. And in this one, you can see that you have three variables, n, d, and q, and they store integers. N is initialized at 10, d is initialized at 2, and we have an if statement. If d is not equal to 0 and n mod d is equal to 0, it would output d is a factor of n. And then on the next part, d is initialized of 0. Now we would set d to 0. Since d is 0, the second operand is not evaluated. So therefore, you would see that here, it would ignore that as we're using the short circuit. And then on the last part, here we would have, again, just the regular logical operator AND. If d is not equal to 0 and n mod d is equal to 0, then we would output d is a factor of n. So for this part, both of the expressions are evaluated as we're using the logical operator and allowing the division by 0 to occur. So you can test this program to really examine how the logical operator and the short circuit operator is being used in the program. Next, I'm going to talk about assignment operator. And there are a few lab activities that tie back to this. Assignment operator can be used with an equal sign, as we would assign a value like x is 100, y is 100, or z is 100. We can use it if, let's say that if these three variables are all assigned to 100, we can type them individually in 3 lines, or you can have x equal y equal z equal 100, and that simply assign all 3 variables to 100. And you set those to 100. So for the shorthand assignment, we would use a shorthand assignment operators, and sometimes refer as a compound assignment operator, in that we can combine different assignment operator along with the arithmetic operator to show the shorthand assignment. So here we have x is x plus 10. So we can use it as a shorthand by doing x plus sign, and then you add an equal sign next to it, and then the value. So I can shorten it and minimize the x by just typing out x plus equal 10 and semicolon. So that would tell us that it is x plus 10. So the operator tells the compiler that to assign x the value of x plus 10, as is noted on the bottom of that page. So on the next page, you also see example on how we would be able to use the subtraction arithmetic operator with the equal sign. So we can use the minus and the equal to make it where it's x is x minus 100. And on the same page, you would see the arithmetic and the logical shorthands, how these can be combined. So take notes that the equal is always following the arithmetic operators or the logical operators. It doesn't go before. Otherwise, you're going to get an error. I've seen some students make that mistake before. So we can have the longhand equivalent, or the regular expressions as longhand, but if you have it shorthand, you would have the arithmetic operators before, the equal sign, or the logical operators before, and you would combine them. So for the next part, we're going to talk about the type conversion assignment. And we can go from one type to another type, or we can cast it. So in this part, we will take a look at some example on how we would go from one type to another. So on the first part here, it shows you that I is a variable and it is typed as int, or it stores integer. F is a variable and it is a float type. And we would initialize I as 10, and F is assigned to I. So what we will see is that we would have a mix in the assignment. And so the value of the right side is automatically convert to the type of the left side. So when we have the right side, it's going to automatically convert to the left side. And in this case, Java, it's going to check the compiler, it's going to check the type. Not all types are compatible, and then not all type conversion are implicitly allowed, and we need to make note of that. So in the case where you have a mixed type, you have to think about how, if the types are compatible, and in the example that's shown here, what we see is that the right, which is the I, it's converted to float. Integers is converted to float as it's assigned to F. So, important notes, two types are compatible. It needs to, so that way conversion can take place. Destination type is larger than the source type. And those are the two things that we need to take notes of, possibly show up on quiz and final exam. For the example on page 17, it shows you on how we can use long and double. And when we do the conversion, it automatically convert long to double as we go. It takes the right side, is assigned to D as the double, so it converts that to the double. Following that, the notes include casting for incompatible types. And cast simply is an instruction for the compiler to convert one to another type. So in the case where we can say, okay, if we're going from integer to double or double to back to integer, how that works. And cast simply narrow the conversion. So in some case, what you see is information might be lost. So when you work with cast, all that is it converts the outcome to a specific, based on the specific expression. And in the case, if we're going from double to int, some of the information will be lost. So that is important to note when you're working with casting. Here's an example for casting. On page 18 shows you how we would go from int to double and from byte to int. So we would start with x and y, and it's typed as double. B is typed as byte, and I is typed as int, and ch is typed as char. X is initialized at 10.0 and Y is initialized at 3.0. So for I, we want to use int. We went from double to int for X divided by Y. So in this case, what we did was we cast the double to int. Because remember, we started with X and Y as double. So when we cast it to int, the outcome will be truncated. Now for the next part in the program, I is initialized as 100, and B, we would cast I to byte. And here in this example, you see the arrow pointing. It shows that no lost info is here. Byte can hold 100. So the value is able to fit in byte, in the allocated size. So there's no loss there. But if this value is much larger, what will happen is it would not be able to fit in the allocated space. If it's a longer number, right, then it would not be able to fit in the allocated space. Then we would face loss of information. Then for the next part of the program, I is 257. We then cast it to byte. Here we see that there's a loss, as byte cannot hold the value 257 as 255 is the limit. For the last part, B is 80A and CH is char B, and it would we have casted between the incompatible types here, so we would have 88. So then it would convert this value to a letter based on ASCII code. So we would have, it would convert that and it would give you X as it casts to char instead of a number. So here we would see the output as what I described. So for the one up here, you see that it would truncate that and it would give you only portion of the value. So the next part, we're going to talk about operator precedence. Which goes first and which take higher precedence. On page 19 provides you with a table on from the highest precedence to the lowest precedence. So the postfix take precedence over the prefix. Multiplication, subtraction, multiplication, division, and modulus take precedence over addition, subtraction. And you can also see how the relational operator would take precedence over the assignment, like equal to or not equal to. And then that would be taking higher precedence over the logical operators and the shorthand logical operator. So this table or this chart on page 19 is very useful, so make sure that you take a look at that on how you would use these operators and which has higher precedence. That means that the compiler would have higher, would operate those operators first. So for expressions, here are some of the 4 things that we need to think about when we have type promotions, when we convert the type. First, all char, byte, and short are promoted to int. So when you're using it with int, they can be promoted to int, char, byte, and short. Then if one operand is long, the whole expression is promoted to long. So any time that you use long in the expression, it would then promote to long. If the operand is a float, the entire expression is promoted to float. So if you have one that's using float, the rest will be promoted to float. If any of the operands is double, the result is double. So double is casted there. So make sure that we take a look at those 4 key points for type promotion on page 19. You will likely see this on quiz and final exam. And also shown, many of the students in the prior class told me that this program also very helpful when you're trying to understand type promotion. So I recommend that you run this example program so you can take a look and you can play with the values and see how it is typecast and what would be the output. So in this program, you have the main, you have byte B. B is type byte. I is storing integers. And so when we're casting it, as we previously saw in the last portion of the note, how it needs to be casted to int as we're going from byte to int. So we need to cast it here in this part of the program. As b is, we convert it from byte as b times b. So b times b is going to be 100, and that would still fit in byte, but when we get a larger value, we need to cast it so that way we can store a larger value. Below that provides you with the explanation. And the last part of this, it talks about spacing of parentheses. It just increase the precedence in the operations that's contained between them. So when you put things in parentheses, when you put expression in parentheses, that's going to take precedence, just like how you've seen this in algebra. You should be using parentheses to specify the order of evaluation in the expression, and that's important to note. Okay, so make sure we use parentheses accordingly. If you don't, you will get a different result. And this, on the last part on page 21, it also provides additional example on how you should use spacing. It's just for readability. For your code, it's clear, it's easier to see. And so when you need to debug or when you need to go back and take a look at your code, it's visible. Instead of using no space, it's difficult to read, and you can easily make mistakes. So 21 gives you some hint on how to use spacing and making your code readable, and so that way it's easier to detect error. Okay, and so this will conclude part 2, which covers operators, different types of operators. Please watch my next video for part 3, where I cover control statements and how to use control statement in a Java program. Thank you very much.